my little jaunt to the city of Alzan, I thought maybe I'd, take a trip to the country, have a nice walk in these lovely autumnal woods before the winter comes in. Excuse me, I think I'm going to be sick. It's shameful what people leave around the forest these days. Shocking. If one of these caught fire, me and the lads have to go out, get our choppers and chop down trees to save the rest of them. Today's game is all about forest fires. There's a lightning storm in the forest, trees are on fire, and it's up to us to save what we can. Hosepipe, that's no good in the forest, mate. No good at all. There's too many trees, not enough water. Our two choices are use our axes to chop down trees and create a backfire that'll block the flames. If that doesn't work, we have to drop nasty chemicals from planes onto the forest in a desperate attempt to stop the fire. So, remember, only you can stop forest fires.
Today's game is from Stimulating Simulations, second edition by C.W. Engel. This was first published in 1977. My version is 1979. It's a grid. What are we playing? Is it battleships? It is not battleships. The game we are playing is Forest Fire. Forest Fire, there's a lightning storm, has ignited trees in a forest. The fires are represented by the asterisk, the trees by the full stop. The forest is in a 9x9 grid. How do we stop the fire? Well, you can drop chemicals on the fire. Each time you drop chemicals, it affects the square you drop it on and the 8 surrounding squares, and has a chance of reducing the intensity of the fire by 3. Fires start out as burning for 9 turns. If you drop chemicals successfully, that is reduced by 3 to 6 turns. So if you drop 3 chemicals successfully, the fire will go out. However, fires can also spread. We see here both for all 3 fires are spread to a neighbouring square, so we now have 6 fires. The game continues until all fires are put out. Once a fire burns out, it leaves an empty space where fires can't spread. So the fires are spreading and not doing a very good job. The other option you have, which you will see eventually, is the backfire. So here I'm dropping chemicals on row 6, column 5. Because there are 3 fires there in the area, so maybe I'll put some of them out. All we know is that a fire is there. We don't know how strong it is. This is not going well, is it? The chance of a fire spreading to a neighbouring square is 70%, so fires can very quickly get out of control. We have our first burnt out square in between the 4 fires there. This game runs on the ZX81. I've typed it in on the ZX81 as part of the Centre for Computing History charity. I did it live on Twitch. It took about 45 minutes to type in. The game takes just about 2K of memory. Obviously, there are no particular graphics apart from the characters we use. The ZX81 did not use ASCII, it uses its own character set, so these aren't even ASCII graphics. And each turn will display the characters on the screen. Stars are fires, dots are trees, spaces are burned out areas, and the fires are raging out of control. So there's no wind in the willows here, just flame and death. Well, where will the squirrels go? At least Badger is safe underground. So now I'm using the other technique I've used, the backfire. You do that by selecting 0 for the row. A backfire is a very special fire that burns out in one turn, creating a fire break. But it only affects one square, so it's no good at stopping massive fires, and you need to have a solid line of them to stop the fire. I think here I've left it too late for a backfire to be effective. I'll need to block off most of the map if I can. But I might be able to save a small amount of trees. And also the character for the backfire is the same as a normal fire, So on this next screen, you won't know which one it is. So again, I'm trying another backfire, this time in row 6, column 8. I think I'm trying to save the bottom right-hand corner of trees. I've given up on the rest of the forest. So as well as coming with the source of the program itself, this particular book is educational and useful for the programmer because he suggests minor and major modifications. The minor modifications are obviously smaller changes, and C.W. Engel tells you which line you have to change to make them happen. For example, how do you change the number of beginning fires? And there are also major changes, which says, yeah, work out how to do this. Like, how do you make the grid bigger? You need to do a number of things. Like, obviously, you change as a two-dimensional array, make it larger. But then you also need to calculate the random location of the fires to start with, and the code that checks whether you've gone out of bounds. Things that, adding time to move from one place to another. Here, your firefighters are magical teleporting beings. You could add wind speed and direction. You could have barriers such as lakes and roads, having some sectors burn faster than others. Lots of ideas and possibilities for making it better. So this is the version on the Spectrum. I've typed it in as in the book, just about, apart from clearing the screen now and again. And you can see it's exactly the same. You've got dots, you've got asterisks. And it works about fine. As you can see, I didn't have clear screen to start with. I need to add clear screen, otherwise when we print this stuff, we'll eventually get into the scroll. But it works exactly the same. So how can we make this better? Well, Spectrum has various advantages over the ZX81. We have the choice of, we have colours, and we have graphics, and we have sound. So let's use all of these to start off with, just jazz it up a bit. So on first, we'll obviously clear the screen so it works every time, so we don't scroll off. And then, on line 140, we've got the dot character, which represents the tree. Replace that with the power of character, which is the upward arrow, which does look a bit like a tree. It's not brilliant, but it'll do for now. We're also going to make the border green, because we're in a forest. This makes sense. And let's see how it looks like so far. Yeah, it's green for the forest, and we have little trees and stars, so that's not too bad. Well, we can also add a bit of colour to the text as well. So the characters that do the fire is line 150. For line 140, we've got the upward arrow. So I'll change that to be green ink. So, a nice green tree. Line 150, you got the asterisk, represents the fire. Well, what colour is fire? Well, fire is red and yellow. So let's have ink 2, which is red. Paper 6, which is yellow. And obviously, let's have flashing as well, because obviously it's a fire. Fires are all flickery and that. How does that look like? That's a lot more menacing now with a flashing green. I like that. And you can see here you can drop things on. It works pretty much as before. But let's have better graphics. So what we're going to do is use the Spectrum to create user-defined graphics, which you can have whatever characters you like. This is the user-defined graphics designer by S. Robert Speel, 1982, from Better Programming for your Spectrum and ZX81. So this gives you a nice little screen, which lets you plot the pixels in large size. Like here, you have a nice little 8x8 grid, which will eventually zoom down to be in a graphic. And what we're going to do is create a character, and I'm going to slowly draw a better version of the tree. So it moves around, it beeps whenever you do things, because it's nice to have a beep as a auditory cue that you've done something. So that's the base of the tree. And move around using the cursor keys 5, 6, 7, 8. You press 0 to fill in a square, 9 to empty a square. And it works quite well. And you can see here what you're trying to do. You can do this yourself just with a bit of graph paper. because the left-hand column is 128, then it goes down in powers of 2. Then you put these numbers in. But it's much easier if you can have a program such as this, where you can see what you're doing and say, oh yeah, that's about right. So you fill in the squares. Oh, so far that could be a sailing ship or a sword, perhaps. But no, we're going to make this into a tree. So you fill it in. Nice attractive little tree. Beepity beepity beep. I was going to write one of these myself, and I found it in the book. Thought I'd just use the book version, because it gets to type in something nice, and it's already tested about 40 odd years ago. Well, nearly 38 years ago, of time of writing. We fill in all the squares. And the nice features of this program is it'll show you the character and also a load of the characters together. So if you're using it for like Space Invaders, you can see how it looks on the screen. You press 1 when you're finished, and you get the character and then a load of characters, and also the numbers you have to type into the program in order to use it. So that's what we're going to do now. So we're going to need to create a little loop. I've also created a fire character. So there are 16 numbers we need to put into memory. We're going to use a data statement which we need to read, and then we're going to put into user brackets A, which is the first user-defined graphics, and then do that 16 times and we get our nice characters. Which is the data statement. So this is for our tree. We have 8 numbers which represent the 8 lines of the user-defined graphic. You type these in, and before you know it, you have an improved graphic. Let's have the fire now. Again, a series of numbers. You need 8. Type these in, and away you go. And once you run the program, you can then find the code that does the graphics. So here, I'm going to tidy up the stuff. So what I need is to find the lines that actually do the graphics, which was currently the power of icon. We're pasting that with the graphics mode letter A, which currently is just the capital A, because we haven't changed it yet. And the fire, we're going to change that to graphics character B, which again we'll see as a capital B, because you haven't changed it yet. Once you've run the program though, we'll see it changed. And also now to change the character. So this is the character for a burned out square. That's going to be a normal graphics character of Shift 8, which is a solid black square. So there's a short delay while we run it in. And now we have a forest of little trees and some fires. And that's quite pretty. I quite like that. And it works exactly the same as before, just looks a little bit nicer. There are some other nice features in Robert Speel's book, so we're going to add some of those as well. So we're going to add lightning. As a lightning effect, which not everyone likes lightning, but for the game, the fire is apparently started by a lightning storm. So in the book on page 28, he has a little routine for creating various sounds, one of which is lightning, which gives a nice black screen with semi-randomised lightning bolts and a sort of lightning rumble of thunder, which is rather pretty. It's all done with random numbers. Make the screen flash yellow for the flash and then go back to black. And then we're going to set a variable Q to one of a number. So it's 9,000 plus. It's 1 to some 0 to 7 times 1,000. The idea is we will set Q to 9,000, 9,001, 90, 10, 20, 30, 40, 50, 60 or 70. And the lines 9,000 contain data which are determining how the lightning bolts are drawn. And so there are 8 of these lines. We'll show you how we're typing them in. Just, these are passed into a draw statement. So we're going down and a bit to the left. Then we're going to the right and down. Then we're going to the left and up. So we're juggling all over the screen. It's rather impressive when it actually works. We keep typing these in. Another little bit of data. We like a bit of data. Because this couldn't be machine code. It's got negative numbers. Although that could be a trick. Because you can put negative numbers into machine code if you really want them. Because sometimes, here's the lightning. So that works quite nicely. So here is our user-defined graphics, and towards the end of the game, lots of fires, lots of burnt-out areas, and it's better. However, we're not using a lot of the screen, though. Most of the screen is empty, which is a bit of a shame. So let's expand it up now. So we're going to use rather than 8x8 pixel character blocks, we're going to use 9x9. So that means we're going to need some better graphics. So Robert Speel also provides a user-defined graphics rotator and mirrorer. Because I don't want to have to create individual graphics for each of the 4 squares. So we need like tree top left, tree top right, tree bottom left, tree bottom right. So why not create just one on the left-hand side and then mirror it so we get the left of the tree, the right of the tree, the left of the fire, the right of the fire. And here's this little marvellous program does it for us. It rotates a given user-defined graphic 4 ways and also mirrors it. So what you need to do is type in the 8 magic numbers, as we're doing here. We're trying to create a better tree and a better fire for our new big chunky graphics. And it's not a big program either. So this is the graphic as typed in. I'm going for some kind of pine tree effect. So that works quite well. Then it rotates it upside down. You see, yeah, that's not too bad. Then it rotates it the other way. And that's the one I want. So make careful note of that, because that's going to be the right-hand side of the tree. And then again, it rotates it. And it also mirrors it. So if you create like a nice spaceship effect, you can have, yeah, it going up, down, left, right, and then going backwards and forwards and all kinds of fun like that. So we're going to use those. We've also created a set of instructions. So, we tell you what you need to do. And here are our characters. And the left-right versions work quite well. Unfortunately, they don't really work well between the rows. So the tree has a big gap in between. And the fire, there's no real link between the top of the fire and the bottom of the fire. Because you can't really see what you're doing. This is the end of the game, though. We've got nice chunky graphics, a big load of burnt out fires, and we took 13 turns to do so. So we're getting there. So I then took Mr. Speel's graphics creator, and rather than having 8x8, I made it 16x16. So in this case, we can do 4 graphics characters at once. So what I'm going to do is create a graphic. This isn't used in the game. It's just for fun. But you can see what I'm trying to do here. I'm drawing a nice big graphic of a face, a very handsome face, if I may say so myself, wearing glasses. Oh, that's not quite right. Let's go and edit that a little bit. There we are. And let's have a little space. There we are. Draw a nose and a moustache. Support of a moustache these days. And maybe a little smile. There we are. And when it fills it all in, we can then get to see the... let's sign it. Yes, be nice. We then get to see all the graphics characters, just about works, and displayed nicely. So there's 4 lines of data, except we've lost some. I do edit that eventually. And we can see how it looks like.
I am the god of hellfire, and I bring you fire. I want you to burn.
So I wanted to add some sound to the game, and I wanted some better sound effects, but you can't really do a huge amount with the beeper. And then I found this little program in Sinclair User, reprinted in 1991, but it was first written by Heikki Julkunen in 1987. It's a sampler. It's called Sussa Sample, and Sussa Sample lets you record sound into your Spectrum memory directly using the microphone, and then play it back later. And it's only 95 bytes of machine code. The issue you're going to have is, if you want to have a lot of sound, it takes a lot of memory. My first attempt was with a different program, and that had 32k of sound for one sentence, and then you couldn't get the game in, which is a bit of a problem. This one gives you the flexibility to say how much memory you want to use. The difference from the typed-in version is I've moved the code, which originally sat at 32k. I've moved it up to 44800, so we get a bit more room here. And now I've got a program that's going to say, hello, I've already stored the data, and I'm going to run it and then execute the sample with varying random lengths. Let's go.
What-ho, snorkers! What-ho, snorkers! What-ho, snorkers! What-ho, snorkers!
This idea has legs. So this is the Supreme version, which I should be making available to Mr. Jim Blimey on his website. We've added a number of features from the suggested feature list, provided by CW Engel. We've added the option of change the number of beginning fires, which is a difficulty setting. We've changed the amount of fire burns out each turn, based on the type of tree. We've changed the probability of spread, again based on the type of tree. We haven't changed the grid size, but we have added a travel system, including we've also added wind speed, lakes and roads, and having some sectors burn faster than others. Added some stuff for myself. We also like to have, with Spectrum programs, a loading screen if you can get one. I did one in ZX Paintbrush, which was meant to be a forest fire. I'll try to do it quickly. It looked like absolute rubbish. So I went onto the copyright-free website Pexels and found a nice picture of a fire, which was the background of the Hellfire chappie, and then ZX Paintbrushed it up and got a really rather nice image. The program then needs to load the machine code and other bits and bobs, then the program itself. It takes about 6 minutes to load in total, I believe. Once it loaded, the border goes green as we start setting up the user-defined graphics, and then we ask some questions. Is flashing okay? Some people are sensitive to flashing images, and some people don't like lightning, so by saying no, you turn it off. The option of having a lake, the lake blocks the fire. You can turn it on, you can turn it off. If you turn it off, you don't have a lake. I want to have a lake. The road gives you easy access to travel, but less trees. The less trees you have, the less score you can make. But I want to have a tree, so I can show you how it works. You can have these one type of tree or different types of tree. Different types of tree react differently to fire. Some burn faster, some burn slower. We can have the wind. Again, the wind is either on or off, and it can change. Also, I became aware that most of the game was okay for high contrast, apart from the forest road, which was a yellow dirt road on a green background. So by setting it to black and white, you go high contrast mode, so you should see everything. Difficulty is 1 to 9, which is the number of fires you start off with. I'm starting with 3 fires, which is the default setting. We now generate the forest and the fire. I've moved away from going around the array, displaying it every time, to in fact just displaying strings. We hold the forest as an array of 18 rows and 72 columns. So after the terrifying lightning storm, we have the fire brigade called. We have the instructions. You can pause the video to read if you like. You've seen it before. They'll be in the game. You press any key to continue. We tell you how the game works, what the graphics represent, and so on. Remember, fires spread, and you can drop chemicals on them. Chemicals reduce the number of turns it takes for a fire to go out. It says 3 successful drops, but that will vary because oak trees burn slower, pine trees burn faster. Again, you can use a backfire. Backfires are good. Backfires always work. Your rating is based on the number of trees left. Lakes do not count as trees, neither do roads. We have firefighters now. Firefighters can build backfires only in adjacent squares. Firefighters can also die. And the chemicals you drop on the fire are toxic and cost money. So you're not penalised for spending money, but
I am the god of hellfire!
And we have that rather jolly little speech. So we jump in on turn 7. See, we've already lost one firefighter through being in the same square as the fire for too long. The wind is northwest, which means it's blowing southeast, because that's how wind works. Northerly winds are blowing south. So that means the fires will move from the northwest to the southeast, a nice diagonal line. And I've set some backfires in row 4. Those are the very small fires, and they're slowly to burning out, so it stops that fire going further south. The oak trees have nice pink magenta trunks and green and white leaves, pine trees and dead trees, and there's a lake on the top. So rather nice and busy, nice chunky graphics, that's what we like. I say after every turn it has to calculate the effects, but redisplaying the screen though is actually fast. The firefighters are on a fire square, therefore they're black on a background to move them out of the way so they don't suffer casualties. If all the firefighters die, you lose the game. So now dropping toxic chemicals on row 4, column 5. I'll put out that array of fires next to them. That can have nasty effects on the firefighters as well as positive effects on the flames. Calculate the results, what's happening, what's going on in the fire. It's a big forest. What is going on? Unfortunately, the toxic chemicals have actually killed one of the firefighters. This is not good. One of the ideas I toyed with was having you lose the game if the fire escaped the forest, but then I didn't in the end because it was too hard. So now I can continue dropping chemicals on the forest, going for the biggest area, try and reduce these fires down. The wind is still blowing from the northwest, which is good, which means the southwest of the forest is pretty much safe. So's the northeast, so's the north really, because the wind, it won't go into the wind. It might go next to the wind, but not into the wind. Jump forward to turn 16. The central heart of the forest has burned out. However, the fires are still raging around the side. The wind is still going from the northeast though, which is pretty good. We like this. 2 firefighters left. Moving on to turn 17. The wind has now moved around to the north and now blow directly south. However, by this point, everything to the south of the fires is entirely burned out ash. So I've moved onto the road and I've dropped some chemicals onto row 3, column 6. That's the biggest fire we've got left. The other symbols are the small fires, which are on the way to burning out. So if a firefighter starts on the road, they get to move 4 spaces as long as they stay on the road. If they move off the road earlier, that's it. But in the forest, you're going to move 1 space. So where I'm going to drop chemicals, I think row 4 will be good, column 8. The wind is from the north. The wind won't go from north to south because that would be silly, but it could move from north to not north, or they could die entirely. If the wind does die, I've gone for 3-7. If the wind does die, that means the fire can spread in every direction. This is a bad thing. Pine trees spread fire faster. In my imagination, it's because of the boiling sap exploding or something or other. Dead trees burn faster. Oak trees burn slower. Because it's the heart of oak. We like the heart of oak. So now to move on to the end of the game, all the fires have now burned out, so the game is now calculating to make sure everything is all done, and then it will tell us our final score. There is the 1 tree left in row 8, column 8. Check out The Little Town of Maryville by John Robertson. It's an excellent book that has a 1 tree in it. It's a famous tree. And our rating is 66%. We spent $230,000 and took 27 turns. I think it's a good game as is in the basic version of 2K, and I think I've made it better. Let me know what you think in the comments below. Until next time, remember that I am who?
I am the god of hellfire!
That's right, and don't have nightmares.